Suppose na atay cross-sectional area with an area of A and naay force, perpendicular force exerting on that area. Then, the pressure on that area is equal to the magnitude of the force, the perpendicular force, divided by the area of the plane. In symbols, we have P equals F over A. Natay subscript nga perpendicular to emphasize that the force must be perpendicular on the surface. If it is not perpendicular, then you have to use some trigonometric calculations para makuha ang perpendicular force. Since the unit of force is newtons and the unit of area is square meters, the unit of pressure is newtons per square meter, or simply, this unit is equivalent to Pascal. Naapod tayo ginatawag nga atmospheric pressure. This is simply the pressure of the Earth's atmosphere. Since ang air sa atmosphere has a mass, then it has to be weight. So kanang weight, it will exert pressure sa ato adiri sa surface. And that is called the atmospheric pressure. That is equal to or standardized into 1 atm. 1 atmosphere, atm for short. And this 1 atm or 1 atmosphere is equivalent to 1.013 times 10 to the 5 pascals. Let's have our example 2. In the same room having the dimensions 4 by 5 by 3, what is the total downward force on the floor due to an air pressure of 1 atm? Ang formula nga atong naibalaan is P equals F over A, pero ang ginapangayaw is total downward force, so the perpendicular force. So you just rearrange the formula, you get F equals P times A. We know the atmospheric pressure is 1 atm or 1.013 times 10 to the 5 pascals. And the area, calculate lang nimo, length times width, 4 times 5. So you will get 2.0 times 10 to the 6 newtons. Sa standard calculations, when you involve standard units, do not use or never use atm. Kay dili yun ka makakuha og saktong answer. We always use SI or International System of Units. Standard units. Okay, so tima ni na siya og ayo. Now suppose we have a fluid in a container bakaha or sa dagat or pwede pod gas sa isa container or pwede pod the atmosphere, no? If we take 2 points, P1 sa ubos, P2 sa taas, no? Point 1 sa ubos, point 2 sa taas, and point 1 has a pressure P1 and an elevation of Y1, and the point 2 has a pressure of P2 and an elevation of Y2, and the fluid has a density of rho, then the difference between the pressures at these 2 points is given by the following formula. P2 or pressure 2 minus pressure 1 is equal to minus rho, it means the density of the fluid, times the G, 9.80 meters per square second, times the difference between the elevations, Y2 minus Y1. So, kaning nga formula, magamit mo na siya if we want to relate the two pressures or the pressures of 2 points sa isa ka fluid given its elevations. And if mo consider tawag special case, for example, sa isa ka container nga naay fluid, we take P1 as the bottom of the fluid and P2 as the surface of the fluid. So P1 now, ato siyang ilet as just P without the subscript. And the pressure 2 we change it to PO because the pressure at that point is just the atmospheric pressure. Okay? Sa surface sa liquid, the pressure diha nga point is the atmospheric pressure of 1 atm or 1 atmosphere. And dili na ta, for example, suppose we do not bother sa elevations, but we just interested sa height sa liquid, sa flow, sa container, sa fluid sa container, no? And that fluid has a density rho. Then the previous formula, we can simplify it as follows. We can get the pressure at a depth h in a fluid of uniform density. Pressure P is equal to PO, which means the atmospheric pressure, plus rho GH. Density of the fluid, 9.8 constant, o ang yahang height sa fluid. O if mag-exert ta og another additional force sa surface sa fluid, then it will lead us to Pascal's law, which states that the pressure applied to an enclosed fluid is transmitted and diminished to every portion of the fluid and the walls of the containing vessel. So if you exert pressure to an enclosed fluid, okay, that pressure is transmitted to the fluid. Undiminished, meaning constant, dili siya mababawasan. Okay? To every portion of the fluid, bisag asa dapita, and to the walls of the containing vessel. So this technology is an application of Pascal's law, wherein kung naa kay gamay-gamay nga piston dito sa isa ka side and you have a larger piston sa other side, you can push up as heavy as car, no? Kay gamay ra man ang area, you can just exert a little amount of force and that pressure will be transmitted to the larger piston so that masaka, maalsa tong kotse dito. So we say that the pressure is equal to force 1 over area 1, also equal to force 2 over area 2. The pressure is equal, undiminished, transmitted throughout the fluid and to the walls of the container. As long as this enclosed fluid, kung dili siya enclosed, then the law doesn't apply. Meaning, if the fluid is exposed to the air, to the atmosphere, then this law is not valid. Naapod tayo ginatawag nga gauge pressure and absolute pressure. The gauge pressure is simply the excess pressure above atmospheric pressure. So, kung unsa ang sobra sa atmospheric pressure nga 1.013 times 10 to the 5 pascals, mo na siya imuhang gauge pressure. While the absolute pressure is the total pressure, the atmospheric pressure plus the gauge pressure. So in symbols, you have absolute pressure equals atmospheric pressure plus gauge pressure. And kung imo nang i-relate sa formula, actually the P there is your absolute pressure, PO is your atmospheric pressure, and the rho GH, this is the excess amount, mo na siya ang gauge pressure. Okay, so we go to example 3. Water stands 12 meters deep in a storage tank whose top is open to the atmosphere. Okay, take note, open to the atmosphere. What are the absolute and gauge pressures at the bottom of the tank? Okay, so sa gauge pressure, we simply use the formula rho GH. The density of water, kabalon man taan na nasa table, 1,000 kilograms per cubic meter times G, 9.80 meters per square second, times the height. So that is 12 meters deep. It's a problem, no? 12 meters. So you multiply that and you will get 1.18 times 10 to the 5 pascals. Next, you have absolute pressure. So you just add that value to atmospheric pressure, you will get the absolute pressure. So you have 1.013 times 10 to the 5 pascals plus 1.18 times 10 to the 5 pascals equals 2.19 times 10 to the 5 pascals.